Fatigue failure basic concept and simple solution. This video is all about basic fatigue failure concept for non-metal, thermosetting, thermoplastic, and metal fatigue. The crack initiation point can be stress concentration caused by an embedded particle, a high stress region due to shaft misalignment, high temperature, and so forth. The fatigue crack may seem to open in the direction of rotation. Pieces of material may be carried in the direction of the shaft rotation. Fatigue failure analysis is essential for designing components subjected to cyclic loading. Fatigue is the initiation and propagation of cracks in a material due to cyclic loading. Once a fatigue crack has initiated, it grows a small amount with each loading cycle, typically producing striations on some parts of the fracture surface. The crack will continue to grow until it reaches a critical size, which occurs when the stress intensity factor of the crack exceeds the fracture toughness of the material, producing rapid propagation and typically complete fracture of the structure. Some examples of fatigue failures are given below. Fatigue failure of steel bridges is another significant problem affecting the remaining service life of existing steel bridges. In general, fatigue can be defined as the weakening of steel materials or accumulation of damage at a localized region caused by cyclic loading or repeatedly applied loads. Shows the surface of a bearing that suffered fatigue due to local overload caused by shaft misalignment. Fatigue failures occur during normal use in many bones, especially in those of the leg and foot, due to excessive numbers of high-strain cycles such as those that occur in athletes, military recruits, dancers, racehorses, etc., or due to weakening of the material by osteoporosis, etc. In medical circles, these are called stress fractures. Fatigue failures are often associated with components experiencing cyclic stresses or strains resulting in permanent damage. This accumulates until it develops into a crack which propagates and causes failure. The process of damage accumulation and failure caused by cyclic loading is called fatigue. Fatigue failures can be reduced significantly if the development of a fatigue crack is delayed by introducing compressive residual stresses at the surface. Solutions: 1. Eliminating soft decarburized surface after austenitization. 2. Eliminating surface discontinuities, folds and pores. 3. Eliminating coarse microstructure at the surface. 4. Strengthening the surface layers by surface hardening, carburizing, nitriding, and deposition of hard coatings. Subscribe and comment for upcoming updates.